According to the National Electrical Code, specifically Section 338.4, a type SE cable must be used at temperatures not exceeding 90 degrees Celsius. Furthermore, Section 336.26 stipulates that the ampacity of conductors should not surpass the values outlined in Table 310.16 of the NEC. When determining the appropriate ampacity for SER cables, we refer to Table 310.16. In this table, a 4/0 SER cable, when considering its 90 degrees Celsius rating, possesses an ampacity of 150 amps. It's essential to recognize that while the connected equipment might be rated for 75 degrees Celsius, the cable itself must be utilized within its inherent temperature rating. In the instance of this SER cable, it's rated for 90 degrees Celsius, not 75 degrees Celsius. Therefore, the correct interpretation is that the 4/0 SER cable is rated for 150 amps according to the 90 degrees Celsius column in Table 310.16 of the NEC. This holds true irrespective of the 75 degrees Celsius rating of the connected equipment. The cable's insulation temperature rating dictates the maximum ampacity that can be used. It's crucial to understand how to properly determine ampacity based on cable type and temperature rating, ensuring adherence to NEC standards for safe and compliant electrical installations. In summary, the steps to determine the correct ampacity for SER cable are: firstly, identify the cable type and size, which is 4/0 SER cable in this example. Secondly, locate the appropriate table in the NEC, specifically Table 310.16. Thirdly, determine the temperature rating of the cable insulation, which is 90 degrees Celsius in this case. Fourthly, find the ampacity value corresponding to the cable size and temperature rating in Table 310.16. For a 4/0 SER cable with a 90 degrees Celsius rating, the ampacity is 150 amps. Fifthly, apply any adjustment or correction factors as required by the NEC based on ambient temperature or the number of current carrying conductors in a raceway or cable. Sixthly, ensure that the ampacity does not exceed the termination temperature rating of the connected equipment, such as circuit breakers or panels. If the equipment is rated for 75 degrees Celsius, the cable ampacity must be limited to the value corresponding to the 75 degrees Celsius column in Table 310.16, even if the cable is rated for 90 degrees Celsius. However, in this case, since the cable ampacity is already determined by its 90 degrees Celsius rating to be 150 amps, and this value does not exceed the equipment's 75 degrees Celsius rating, it is acceptable. Seventhly, consult with a qualified electrical inspector or engineer if there are any doubts or questions regarding the correct ampacity for a specific installation. Understanding and applying these steps is crucial for ensuring safe and compliant electrical installations. Remember, the NEC is a comprehensive set of standards, and it's essential to stay updated with the latest revisions and interpretations. Also, the proper selection and installation of electrical cables are paramount for safety and performance. Always prioritize safety when working with electrical systems and consult with qualified professionals when needed. Let's delve deeper into the specifics of SER cable ampacity and the NEC requirements that govern its application. SER cable, or service entrance cable, is commonly used to bring power from the utility company's transformer to the main service panel of a building. Its ampacity, which is the maximum amount of electrical current it can safely carry, is determined by several factors, including its size, insulation type, and installation conditions. The NEC provides detailed guidelines on how to determine the correct ampacity for SER cable, taking into account these factors. As previously mentioned, Table 310.16 is a crucial resource for determining ampacity. This table lists the allowable ampacities for various conductor types and sizes based on their insulation temperature ratings. The insulation temperature rating refers to the maximum temperature that the conductor's insulation can withstand without degrading. SER cable typically has a 90 degrees Celsius insulation rating, but it's essential to verify the specific rating for the cable being used. When using Table 310.16, it's important to select the correct column that corresponds to the cable's insulation temperature rating. For a 90°C rated SCR cable, the 90°C column should be used. The ampacity value listed in this column for the corresponding cable size is the maximum allowable ampacity for the cable, provided that all other conditions are met. However, it's crucial to consider the termination temperature rating of the connected equipment. Electrical equipment, such as circuit breakers and panels, also has a temperature rating which indicates the maximum temperature that its terminals can withstand. If the equipment's temperature rating is lower than the cable's insulation temperature rating, the cable's ampacity must be limited to the value corresponding to the equipment's temperature rating. For example, if the equipment is rated for 75°C, the cable's ampacity must be limited to the value in the 75°C column of table 310.16, even if the cable is rated for 90°C. In the case of the 4/0 SCR cable, its 90°C ampacity is 150 amps. If the connected equipment is rated for 75°C, the cable's ampacity must be limited to the 75°C value, which may be lower than 150 amps. It's important to note that the NEC also includes adjustment and correction factors that may need to be applied to the ampacity values in table 310.16. These factors account for conditions such as high ambient temperatures or the presence of multiple current-carrying conductors in a raceway or cable. High ambient temperatures can reduce the cable's ability to dissipate heat, which can lower its ampacity. Similarly, multiple current-carrying conductors in a raceway or cable can generate more heat, which can also lower the ampacity. The NEC provides detailed instructions on how to calculate these adjustment and correction factors. In addition to the NEC requirements, it's also essential to follow the manufacturer's instructions for the SCR cable and the connected equipment. The manufacturer's instructions may provide additional guidance on installation and ampacity rating. Understanding and applying these NEC requirements and manufacturer's instructions is crucial for ensuring safe and compliant electrical installations. Always consult with a qualified electrical inspector or engineer if there are any doubts or questions regarding the correct ampacity for a specific installation. Proper selection and installation of electrical cables are paramount for safety and performance. Remember, electricity is a powerful force, and it's essential to take all necessary precautions to prevent electrical hazards. Always prioritize safety when working with electrical systems and consult with qualified professionals when needed. Let's further clarify the relationship between the cable's temperature rating, the equipment's temperature rating, and the resulting ampacity limitations. The NEC prioritizes the safety of electrical installations, and one way it achieves this is by ensuring that the weakest link in the system is protected. In this context, the weakest link refers to the component with the lowest temperature rating. If a cable with a high temperature rating is connected to equipment with a lower temperature rating, the equipment becomes the limiting factor. The reason for this is that the equipment's terminals cannot safely handle the heat generated by the cable operating at its full 90°C ampacity. Overheating terminals can lead to insulation breakdown, arcing, and potentially fire hazards. Therefore, the NEC mandates that the cable's ampacity be reduced to match the equipment's temperature rating. This ensures that the equipment operates within its safe temperature limits. To illustrate this concept, consider the example of a 4/0 SCR cable with a 90°C rating connected to a circuit breaker with a 75°C rating. The 4/0 SCR cable has an ampacity of 150 amps at 90°C according to table 310.16. However, the circuit breaker is only rated for 75°C, which means its terminals cannot safely handle the heat generated by 150 amps. In this case, the NEC requires that the cable's ampacity be limited to the value corresponding to the 75°C column in table 310.16. This value is typically lower than 150 amps. By limiting the cable's ampacity, the amount of heat generated at the circuit breaker terminals is reduced, ensuring that the breaker operates within its safe temperature limits. It's important to note that this ampacity limitation only applies at the point of termination. The cable can still carry its full 90 degrees Celsius ampacity along its length as long as it's installed in accordance with the NEC requirements. However, at the point where it connects to the 75 degrees Celsius rated equipment, its ampacity must be reduced. This concept is often misunderstood, but it's crucial for ensuring safe and compliant electrical installations. Always verify the temperature ratings of both the cable and the connected equipment and apply the appropriate ampacity limitations as required by the NEC. Ignoring these requirements can lead to dangerous overheating and potential fire hazards. Furthermore, consider the practical implications of using a cable with a higher temperature rating than the connected equipment. While it may seem like a waste of money to use a more expensive cable with a higher temperature rating, there can be benefits in certain situations. For example, if the cable is installed in an area with high ambient temperatures, the higher temperature rating may allow for a higher ampacity after applying the necessary correction factors. In this case, using a cable with a higher temperature rating can be advantageous, even if the connected equipment has a lower temperature rating. However, it's essential to remember that the cable's ampacity must still be limited to the equipment's temperature rating at the point of termination. In summary, the relationship between the cable's temperature rating, the equipment's temperature rating, and the resulting ampacity limitations is a critical aspect of electrical safety. Always prioritize safety and consult with qualified professionals when needed. Now, let's address some common misconceptions regarding SER cable ampacity and NEC requirements. One common misconception is that the cable's ampacity is solely determined by its size and insulation type. While these factors are important, they are not the only determinants of ampacity. As we have discussed, the termination temperature rating of the connected equipment also plays a crucial role in limiting the cable's ampacity. Another misconception is that the NEC allows for the use of the 90 degrees Celsius ampacity for all 90 degrees Celsius rated cables. This is not always the case. The NEC specifies certain conditions under which the 90 degrees Celsius ampacity can be used. These conditions typically involve specific types of equipment and installation method. In general, the 75 degrees Celsius ampacity is the default value to use, unless the specific conditions for using the 90 degrees Celsius ampacity are met. A further misconception is that ampacity adjustment and correction factors are only necessary in extreme cases. This is not true. Ampacity adjustment and correction factors must be applied whenever the installation conditions deviate from the standard conditions assumed in Table 310.16. These conditions include high ambient temperatures, multiple current carrying conductors in a raceway or cable, and specific types of equipment. Failing to apply these factors can lead to overheating and potential fire hazards. It's also important to note that the NEC is not a design manual. It provides minimum safety requirements, but it does not provide detailed design guidance. Electrical engineers and designers must use their professional judgment and experience to ensure that electrical systems are safe and reliable. The NEC is a constantly evolving document. It is updated every 3 years to reflect changes in technology and best practices. It's essential to stay up to date with the latest revisions of the NEC to ensure that electrical installations comply with the current requirements. There are many resources available to help electrical professionals stay informed about the NEC, including training courses, seminars, and online publications. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It's important to check with the local authorities to ensure that all applicable codes and regulations are followed. Proper electrical installations are not only safe but also efficient and reliable. By following the NEC requirements and using sound engineering practices, electrical professionals can ensure that electrical systems provide years of trouble-free service. Safety should always be the top priority when working with electricity. By taking the necessary precautions and following the NEC requirements, electrical professionals can protect themselves and others from electrical hazards. Finally, let's emphasize the importance of consulting with qualified electrical professionals for all electrical work. Electrical work is complex and potentially dangerous. It should only be performed by individuals who have the necessary training and experience. Qualified electrical professionals have the knowledge and skills to design, install, and maintain electrical systems safely and reliably. They can also ensure that electrical installations comply with all applicable codes and regulations. Attempting to perform electrical work without the proper training and experience can be extremely dangerous and can lead to serious injury or death. Always hire a qualified electrical professional for all electrical work, no matter how small or simple it may seem. By doing so, you can protect yourself, your family, and your property from electrical hazards.